Hey guys, this is Miss Regine from SOAR Educational Services, and today we're going to solve some problems with trigonometric functions. And without a calculator. So let's try this. So we have to find sine 300. So we just talked about the unit circle. So this is 90, this is 180. Some of it you do have to memorize some things. So let's know how our unit circle looks like. And now if we're trying to get to 300, we're at 270 degrees right here. To get to 300, we just need to add 30 more. So now in adding that 30 more, from the difference between 270 and 300 is 30 more. So I did a little mental math from that. So this is our 300 degree mark is. But now if we actually want to know what the reference angle is for this angle that I just drew, it really is the difference between this number 360 minus 300. So our reference angle is 60 degrees. So you do have to realize that I moved up 30. The whole quadrant is 90, but it's the difference between them. So it's 60 degrees. And here I have my right angle. And if you recall doing your 30, 60, 90. So now here we have our 30, 60, 90. So now if we're trying to find out what sine 300 is, so this is our reference angle. So if we say our 30 is 1/2, that's just maybe we can start thinking of it this way. The hypotenuse, the one across, and this is called a unit circle. So the hypotenuse, the one across from the 90 degrees is one whole. So maybe that we'll consider that our standard. The hypotenuse is one whole. The rule is, and you learned a little bit of this in geometry, but the angle that's across from the 30 is always half of whatever the angle across from the 90 is. So if this is 1, the one across from the 30 is 1/2. And the one across from the 60 is, you take this number and you multiply it by the square root of 3. So in this case, it'll be 1/2 times the square root of 3. So square root of 3 over 2. So if I have an angle that's sine 300, sine, remember, is opposite over hypotenuse. So opposite is square root of 3 over 2 over the hypotenuse of 1. Anything over 1 just stays the same. So that's my sine of 300, square root of 3 over 2. Okay, let's try another one. All right, cosecant of 5 pi over 3. Okay, so this is in radian, but again, let's draw our unit circle. So this is pi half, this is pi, 3 pi half, and 2 pi. Okay, we're looking for 5 pi over 3. So I know like 1/3 pi is about right here. Then we have 2/3 pi, this is 3/3 pi, 4/3 pi, 5/3 pi. And again, some of it, like I said, you try to go by memory, but 5/3 pi will be right here. So think about breaking the top half of your unit circle into 3 parts. So like this could be, 1/3 pi. This could be 2/3 pi. Maybe a little smaller, 3/3 pi. Remember, anything where the numerator and denominator are the same, that's how you get your one whole. So this is 3/3 pi. 4/3 pi would be probably about right here. So now this is 5/3 pi. Okay, so now 5/3 pi is right here. And if I want to find the difference between 2 pi and 5/3 pi, so 2 pi minus 5/3 pi, what you get is pi over 3. So you get 1/3 pi. And 1/3 pi, and some of it, like I said, you can use that rule we did before, but try to memorize as much of it as you can, but especially if you're not using a calculator. So you can cross multiply here, and 180 over 3, and that's 60 degrees. So 1/3 pi is equivalent to 60 degrees. And I just do that. I don't use the 1/3 pi. I use 60 degrees because I have it better memorized in degrees. So I use 60 degrees. And actually, well, except we're doing cosine this time. But other than that, it's what we just had before. So I didn't solve for it, but it's what we just had before with the 300 degrees. Okay, so we remember where everything was placed. So now cosine, though, is adjacent over hypotenuse. So if 60 degrees is my reference angle, then adjacent to that 60 degrees is 1/2. And the hypotenuse is 1, but 1/2 over 1 is just 1/2. So cosine of 5 pi over 3 is 1/2. Okay, secant of 3 pi over 2. So we just draw our unit circle like normal. Okay, I know. This is 3 pi over 2 right here. This is what we're looking for. So secant is the reciprocal of cosine. Now, in our unit circle, these are called quadrangles. And in our unit circle, this point 3 pi over 2 is 0, -1. And cosine is associated with the x value, 0, and sine is associated with the y value. So since we're doing secant, let's first solve for what is the cosine of 3 pi over 2. So the cosine is the x, so the cosine is 0. Okay? So now if our cosine is 0, but I said secant is the reciprocal of that. So reciprocal means that you can just put it over 1. So we have 1 over 0. Cosine was 0, but now we're going to put it 1 over 0. And just an algebraic rule that, well, you've been learning, so important algebraic rule, you cannot have anything 0 in your denominator. So this is undefined. So even if you were asked to draw the graph of this, when it's at 3 pi over 2, you would draw an asymptote or something to show that this is undefined. So secant of 3 pi over 2 is undefined. All right, let's try cotangent of 11 pi over 6. And if you guys are starting to get the hang of it, you can definitely pause the video and see what you're able to solve on your own and then come back and check. So cotangent of 11 pi over 6. So we have, our starting point is 0. We have pi half, pi, 3 pi over 2, and 2 pi. Okay, so 11 pi over 6. We know this is 6 pi over 6, right? And this would be 9 pi over 6. And over here, if we made the full circle twice, that would actually be 12 pi over 6. 12 pi over 6 would equal 2 pi. But we need 11 pi over 6, so it's just slightly smaller. So if you notice, it should have been 12 pi over 6 if we got to the end of it. Because 2 pi is 12 pi over 6. But we're actually at 11 pi over 6. So the difference is just pi over 6. And you can use this formula to help you figure out what 11 pi